Good morning, everybody. Welcome to I want to thank you for being a participant in the 50th NCECA conference and the very first, the Clay Fab Lab at NCECA. And my name is Shoji Sataki, and I am a professor at West Virginia University. I'm better known as Jen Allen's husband, and we're really excited to do what we're doing here today. Andy and I have been talking for a while about why we thought this was a great idea, and for the last several years, there's been a lot of great presentations, panel discussions about 3D digital technology at the conference, but there really wasn't any demonstration, any active work being made, and so that we thought this was a great way to formally introduce some of the artists in the field that are working with this innovative technology and some really long-lasting existing technology, and do it as a 3-year project. So this is our first of our 3 years, and we will follow this up with hopefully even more improved, better programming in Portland, and that I need your help. As you guys visit us today and tomorrow, if you have suggestions or recommendations and things you like, we really want the feedback so that we can continue to make this program better. But I quickly want to introduce Andy so he can do his presentation, and quickly after that, after his presentation, there'll be about a half-hour break for resetup, and then Andy and Brian Seabaz and Richard Burkett will be doing their demonstrations with their actual machines. So Andy Brayman, he owns the Matter Factory, and he's a product of the city. He's a local boy gone good. He's been one of our innovators in the field in ceramics with the digital programming and digital printing. And he graduated with his undergrad degree from University of Kansas and then went off to Alfred for his MFA. And he'll tell you more about what he does. And if you guys can all find a seat. And just a reminder, make sure you have your ringer off on your cell phone. We are streaming this live right now. So if you can't get here and you're in the area and stuff, if you can go to the 90-second wide virtual Clay site, it's actually being streamed live today and tomorrow with all the presentations and all the demonstrations. Right? So, without further ado, this is Andy Brayman.
Thanks for coming. This is informal. You can ask questions as I go. And of course, during demonstrating, that's a really good time to ask sort of the really sort of geeky technical questions, of which there are many, which I should just start off and just say like that I think the sort of hype around new technology is sort of justified because there is a ton of potential there to do things that really different tool sets don't give us. But there's also a ton of limitations, there's a ton of problems, there's a lot to be critical of with these tools, I think. So sometimes people can be, sort of labeled Luddites or whatever by, in being critical of this stuff, and I think sometimes that is true. Sometimes people have knee-jerk reaction and kind of judge this stuff before they really sort of understand it. But as somebody that's been working with digital tools for a while in my practice, I feel like I'm in a pretty good place to talk about it critically. And there's a panel in the afternoon. We're going to do that a little bit more. But I just wanted to give an overview, and then mostly of my own work, with an emphasis on kind of showing where some of the digital technologies can be used that maybe you are unfamiliar with, or just to give kind of a broader scope of what these tools can do. So on the screen, if we could see the first image, oh, I guess it's over there. So that's this machine, and that's when it was fairly new, and it's called a CNC machine, and so it is a computer numerically controlled machine. And it's really remarkably sort of stupid in the sense that it will only sort of do exactly what you tell it. It will only go from one point to the next. And it can be used either subtractively or additively, typically. And so the conventional use of a machine like this is to work subtractively, to remove a material, whether it be foam or plaster directly, or of course other materials, right? And so that's one thing that the digital tools seem to do is they sort of open up a lot of other materials to come into the studio because the fabrication processes typically aren't that different. There's just a few little minor changes to move from one material to the next. And there's also the ability to sort of scale, right? Scale in a way that the human body can't, perhaps. This particular machine is sort of a small machine, really, for a CNC machine, and they can scale up tremendously. But a lot of times when we look at this stuff, the emphasis is sort of on the machines themselves, or sort of going from digital to physical. And for the demonstration later today, I'm going to spend time on the front end, really, so on the software side of things, which is really where a tremendous amount of the sort of like potential lies. Okay, so I'm going to go through, this is just like a mold that was milled with the machine. And these are some things I've shown in the past, but it's sort of chronological in terms of how I've been working with the material. So this is a mold, a digital mold for a series of handles. It's a spin casting mold. That's it in sort of, real life, physical space. And this, what you'll see here, this is a screenshot of a program that I and a lot of artists who are sort of working with digital tools, specifically a type of programming. It's a software package called Grasshopper, and it's really designed to be able to work with code, but with an emphasis on the visual. So it still is programming, it still is sort of writing code, but it's visually based more so than text based. Okay, so these are some cups. And really, most of my research, really, and it does feel like research a lot of times. I mean, sometimes it's sort of play, and sometimes it really does feel like what I and other people are doing is more akin to kind of like the rigor of research as opposed to just play. And the reason I say that is the learning curve can be really brutal, it can be really difficult, and it pushes people away from these tools. And I think for some people, rightfully so, I think unfortunately the tool set that we now have, the software that we now have, it's like you have to really see the potential in your own work to use these tools, because it has all the potential to just be a huge distraction and just be this like thing that would keep you from really making art if that's what you want to do, right? And that there are people who are really sort of maybe can deal with this sort of complexity or sort of are interested in complexity that it makes sense with, this tool set. But if that's not your thing, then it doesn't mean you don't have access to this stuff. I think there's a real argument to be made that a lot of these tools probably would be best used in sort of like the setting like a glass shop might, right? Where you have a team of people working together to produce something collaboratively. And I think that's a nice sort of model to sort of like apply to this digital tool set, which of course you see in other fields like architecture and design, where often files are handed off and there's a sort of a division of labor and a division of skill sets in order to make things, right? Which is totally different than sort of contemporary, or at least the last century, the idea of sort of studio pottery as a single individual in their studio working, Okay, so what happens with the digital tools is it sort of opens up all kinds of possibilities that maybe are not what you would think. Oftentimes these tools are sort of, the first things that come to mind are sort of like efficiency, speed, maybe production. And I mean, of all the people I know working in, say, ceramics even with digital tools, it's like hardly any of those are the words that you would use to describe their practice. I mean, it's often slower, less efficient, just a nightmare to like figure out how to do it. And some of that is because it's sort of people are inventing like the methods to do some things that, you know, down the road would be a little more sort of basic and proven, right? I mean, ceramics, we have the great history of just like centuries of people sort of figuring out workflows that get passed down sort of orally or however, and we don't have really the benefit of that yet in the digital tool set. Of course, the tools are sort of based on real life oftentimes, and so like in the package I use a lot, Rhino, you know, a lot of the tools are based on sort of physical ways that you might build something, right? And you'll get a chance to see that. So these are sensors and data that's being used sort of in the studio to drive different things in the geometry. So here's like a little weather station. And so what that information can do is it can affect or change like a three-dimensional object, basically. So bringing in data as a way to sort of have a voice in the early stages in the design process, mostly not for efficiency, of course, but for a kind of conceptual layer there that is not necessarily available without these tools, where you're having data drive things really directly. So I'm going to skip over some of this stuff and get to some newer things. These are vases. And so this is an example of a tool head. So for all the machines in here, they have what's called like the end effector, or the tool head. And that can be changed out or swapped out. And there's a lot of sort of like research and play that really deals with that. So people building their own sort of hardware. And in some ways, for people like in the studio, that seems like really sort of like obvious. Like potters have made their own tools from the beginning, right? And we also know the impact of changing your tools. You know, if you traveled somewhere and you didn't have your tools and had to use someone else's tools, it's like it mixes things up. And so that can be like a strategy, right? Or it can be potentially a limitation if you're tied too close to a tool set. But with the digital tools, is they're changing all the time. I mean, your iPhone, you have to update to the newest like operating system, and you're like, oh, there's a sense of dread, right? Sometimes, or I have that. Like, God, how is this going to change everything? And with the digital tool set, that's also the case. Like, they're constantly, you know, it's driven by commercial markets, so they're constantly like having to sort of invent or make new things, and sort of incorporating that into one's practice can be good, and it can also be like a real problem. But that's the sort of software side. For the hardware side, the tool heads seem to be like the area that people focus the most in terms of development. And so this is an older tool head that's just sort of spraying some plates with decoration. And that's like a China paint, or it's an in-glaze pigment, so a high temperature sort of. Okay, so this is a screenshot of sort of these plates with decoration. So one of the things that people who are working in ceramics often sort of are attracted to with digital tools are sort of, it's this sort of promise that's really difficult to fulfill. But it's that you could sort of have production speeds, but all the variation and all the sort of flexibility that comes with sort of like working, say, on the potter's wheel. And I mean, I will tell you, that just it's not possible yet. That doesn't really sort of work. But I think in a lot of people's practice, that's what they're working towards, or that's sort of a goal on some level, is to be able to have this thing. This feedback loop is often the way people talk about it, where, you know, you're making something, let's say the wheel, and you're getting feedback as you make it, right? You can see the profile, you can look at the edge of the pot, and you can change it like right then and there, right? And you don't have that with digital tools. right? So it's this workflow that's just brutal oftentimes, and the idea is to sort of shorten that sort of feedback loop as tight as possible so that you can make sort of changes. I mean, and that sort of extended feedback loop is one that we, in some ways, should be comfortable with in ceramics. I mean, we don't fire our kilns like that. We have to glaze them, and they're not the right color, and then they sort of come out of the kiln, and we get that information. It's why people build small kilns sometimes, right? It's just like that feedback loop. So with the digital tool set, that depending on the sort of workflow, the chain of software to digital, model to then physical output, that can be really long or hopefully a sort of a shorter process. So this is a screenshot of, a picture of just like how some of the hardware is built, and it's not everybody's sort of foolish enough to kind of go to the lengths that like I go, but let's be honest, like a lot of the people who are doing this now, the sort of earlier adopters, are very kind of into the tooling, right, and the sort of geekiness of all of it and the process of all of it, right, and so I fit into that camp, right. So this is like an diagram of sort of one part of the process. This is trying to build, like for my machine, to be able to do things that like a really slow person could do. Like the more I use the machines, the more I'm like, humans are fucking incredible, It's like unbelievable how sophisticated the brain is and the body, right? And so really, as much hype as there is around sort of artificial intelligence and things like that, it's like the tool set that most artists are really dealing with is totally rudimentary. And it can excel at certain things, very specific certain things, in which I can kind of get into. So this is this machine with this tool head here, so cutting out a wet slab. And this is what I'm going to do later in the morning. And this is the definition to do that, to like write the information, write the instructions for the machine to tell it how to move all four different axes that it has at the same time so that it ends up where it's supposed to, when it's supposed to. And this is sort of a simulation of like a cut of 45-degree angles on a slab. And this is sort of just early tests of, kind of like what does this tool sort of do. And it's the same thing for somebody who's sort of hand building, where it's like you have a new tool and you sort of try it out and you kind of maybe have an idea what it's going to do or how it might change the work. But, the thing with these workflows that I keep talking about is there's the software end has arguably more power, more sort of potential than the hardware. And I think as a community, we mostly have focused on sort of giving attention to the hardware side because it's a little closer to like physical. It is physical, right? So it's a little easier to wrap our heads around that. And most of us weren't trained with software for 3D modeling. So it's sort of way more foreign. Okay, so now I'm going to get into some other areas. So this is a wood kiln at KU, and that Marshall Maud sort of organized this firing, and we talked about an idea of sort of collecting information from a firing, and John Ballesteri did a firing. This was a while ago, a year or two ago. But so I decided, well, I'm going to try and collect a bunch of information from this firing. And I don't know if you can see that. This is, I think, a graph of just the temperatures in the kiln, and then it also has some other information. It's got overlaid on top of it. And clearly I'm doing this because I'm just interested. I'm just curious. No one's paying me to do this. I'm not exhibiting it as art. I'm just sort of using this tool set and sort of learning by tackling these different things that I'm sort of interested in and curious about. And so the dots, if we could see that again. So if there's a blue dot, the temperature's going down. If there's a red dot, it's going up. The dots are where people stoke the kiln. And then if we look closer, it's, well, this is a little scale that's connected to the computer. So as people would put the wood on the scale, it would weigh it. And then it just feeds that to the computer. It logs that. And then when they're ready to stoke, they had to like push this little button on the scale. And then they would stoke. That way I would know, it'd be like a timestamp. This is when 27.5 pounds of wood went into the kiln. And the point of this was not like, well, let's make a really efficient wood kiln. I mean, because come on, like that's, you know, I'm not saying there aren't efficient wood kilns, but it's sort of not as interesting of just sort of like exploring really, and just sort of seeing this super complex system. Because I think you can make a real argument that the wood kiln is, you know, way more complex than any of the machines in here, right? Like in terms of just the sheer amount of like information and complexity and variables. It just blows this stuff out of the water, right? So it seemed like an interesting thing to kind of like take these tools and put them on top. And then there's a I think it's called the Peter principle. It's when you're studying, if you're a psychologist or sociologist and you're studying a group of people, you can have an impact on them. And so that's what happened here, is that people were sort of weighing the wood and John was firing. And you can see this is a graph of just the wood weights. So where they're located up and down on the graph. So at the top of the graph, it's like a lot of wood. At the bottom of the graph, it's a little bit of wood. And at some point, John was like, well, instead of saying put in 5, you know, logs, he was saying put in 23 pounds. And so they just like, and then he changed and was like, okay, put in 27 pounds. And they started sort of using the tools to fire the kiln. So it had sort of an impact on that sort of process, for better or worse. You know, I sort of don't know, but. And then this is the sheer amount of information that the thing generated was just sort of stifling, right? So I was collecting information every 2 seconds for, I don't remember how many days the thing went, but a long time. You know, it was a big Anagama kiln. And so this is what's called a definition in the software that I and a bunch of other people use. And it's sort of, you can scrub through that information. So you can move these lines on there and you can zoom in on an area and sort of see what's happening when, at least what's happening with the sensors. Okay, so this is a glaze mixing machine. So a lot of these tools, they sort of, like once you sort of figure out sort of how to use sensors and actuators with the software and sort of make a piece of software that's sort of custom to what you want, it sort of opens up a lot of just like weird possibilities. So I thought, well, I could make a little glaze mixing machine, you know. And this one, I was going for efficiency and speed, right? So my goal was like 1,000 glaze tests in a day, just to pump them out, right? And of course, what happens then is everything's always more complicated than one thinks. And so it's like, well, it'll make 1,000 in a day, but then you have to like label 1,000. You have to dip 1,000. You have to put 1,000 on in a way that makes sense and isn't just like a total mess and you can't figure anything out, right? And so then it's sort of the process of kind of trying to design those systems around like, how does that happen? How's it sort of firing? Ian Curry, who passed away several years ago, I think he's Australian or New Zealand. He wrote a book called Revealing Glazes, and I sort of took that as an inspiration for this machine. So it's a wet mixing method that was sort of done in, you know, literally in the outback, right, with little syringes and, you know, liquid and feldspar. And so this is kind of comes from that, right? And so part of sort of my digital interest in exploration, I think like material science and material exploration is like super important and really kind of critical to link with some of the digital stuff. So this is just an example of like experimenting with some of the things I learned from printmaking over the years and decals and trying to kind of take the decal off the printed page and deal with it in like a different way. So basically trying to print things, and what I would love to do is some of like along the lines of some of the research that's happening at MIT, where they're really like designing material. I mean, and a bunch of other places, really making materials on a small level for things. So making aggregates, custom, custom grog, custom sort of materials on a small level, right? Because then, well, what do you do after that? You build a machine to make stuff with that. But this is the, so if you're going to make 1,000 glaze tests in a day, it's like, how do you do that? You don't sit down and write them on paper and then input them into the computer. You use software to sort of deal with that. And so the method of using this machine is really sort of like, it's called brute force testing. So there's a whole field called combinatorial chemistry, and it's mostly used to make drugs, really, legal drugs, where it's like, they just test everything, just brute force, just test the hell out of everything, and then sort of analyze the results, really. Because the world is complicated, and sometimes that's the best. We're not so clever that we know. We just have to empirically just test a ton. So this I'm going to show later, sort of how this works. But it's basically like, instead of a quadraxial blend, which many of us are familiar with, this is something where I could take that shape and twist it or morph it, and we'll make blends. And so in this case, it would be like a color blend. Each corner of this polygon represents, say in this case, a colorant, an oxide, cobalt, manganese, copper, something like that. And so the idea would be, if you're testing a base of a certain type, you might only know you want just a teeny bit of cobalt, let's say. And typically when we make glazes, it's like if there's 3 colorants in the glaze, that's kind of a lot, right? And so, but of course, there's potential to have 6 or more or whatever colorants to get sort of colors that aren't typical in the field, right? And so that's sort of one of the areas where I'm starting to kind of use that. This I'm going to show later, so I'll skip over that. And these are these little jump drives that I make. They're like, a little container for some of the data that people have in their life. I make them really with the thought that they would store things that are not like your NCECA presentation, but something, pictures of your family, of your friends, that type of thing, like sort of a vessel for this sort of, digital world. And I think that there's actually a lot of potential in objects like this that sort of deal with electronics specifically and clay. And that's sort of an area that I'm kind of picking away at. Okay, so that's it. So if anybody has any questions now, I can take a stab at it. Otherwise, people can ask questions as the demos start in about 30 minutes, I think it is. Yeah.
How big can you make something in a 3D?
Well, so the question is, how big can you make something in in one of these machines? And I mean, it's ridiculous, really, what's being done and how fast stuff is being done. A lot of people are aware of sort of like the Chinese government's been printing houses, right, with concrete, and other people have been sort of experimenting with that, sort of large scale, And the thing is most of the tools are sort of good at a narrow set of things. So the tool that would print the house, you wouldn't want to make a coffee cup with, right? Obviously, And, but yeah, the scaling is bizarre, right? So there's printers that can print things that are smaller than a grain of sand. But like, the Parthenon. It's like a little mini Parthenon, smaller than a grain of sand. It's like insane. And, for medical applications, for just sort of pure research, really, on some level. And then there's, of course, the big stuff, right? So,
Okay, so